Dear students, good morning. Now, today's task is known to you. Today we are going to find the moment of inertia of a three-dimensional body about a given line which passes through the origin. Okay. So this is our problem which we are going to use in the coming lectures. So this is the article, our target today. So moment of inertia about a given line in 3D. You know how to represent a line? You can draw a line only when you know the element of that line. So element of this line ON, they are given as LMN. What is L? That is, the line is making an angle theta with x-axis. Then L is cos theta. It is making an angle 90 minus theta with the y-axis. Then sin theta will be M, and similarly N. So LMN, these are the cos of the angles which the line is making with x-axis, with y-axis and with z-axis. Okay. So the very popular equation of a given line in three-dimensional geometry, all of you must have studied. That is x minus x dash divided by L is equal to y minus y dash divided by M is equal to z minus z dash is equal to N. Here what is x dash, y dash, z dash? 0, 0, 0. Because the line is passing through the origin. So let ON be the given line, and we can write down the equation of this line as x upon L is equal to y upon M is equal to z upon N. So this is the given line about which we want to calculate the moment of inertia of a rigid body. The same procedure. We will consider a small mass of the body. So I am considering a small mass capital M present at P. Why capital M? Because small m we have taken already, that is the DC of the line, LMN. And you know the equation, L square plus M square plus N square is equal to 1. That is a relation for the element of a line. Okay. So we have chosen a small particle, capital M. So let capital M is a small mass. It is present at P, and the coordinates for P, of course, we have chosen as usual x, y, z. Okay. So we want to find the moment of inertia of the rigid body. Rigid body is not this. It may be something like this. And this is a small mass particle, capital M, we have chosen, which is present at the point P having coordinates x, y, z. Then the moment of inertia about ON, by the definition of moment of inertia, it is mass into perpendicular distance square. So moment of inertia of one such particle will be m into Pn square. Similarly, you have number of mass particles. For each particle you will calculate moment of inertia, and their summation will give you the total moment of inertia of the rigid body about ON. So what is Pn? Pn is a perpendicular dropped from P on the line ON. That means this angle is pi by 2. Okay. So you can observe that in this triangle, it is a right angle triangle, You know that OP square is PN square plus NO square, isn't it? So PN square is OP square minus ON square. So our target is to calculate these lengths. Now what is OP? That is the distance between two mass particles, distance between 2 points. One point is 0, 0, 0, another point is x, y, z, isn't it? So it will be x square plus y square plus z square. That will be the OP square. Now what I am doing? I am multiplying this x square plus y square plus z square by 1, and we can always multiply by 1. It will give you the same result. But we know that this 1 is also equal to L square plus M square plus N square. So let us replace the 1 by L square plus M square plus N square. Is this point clear? This is simply 1. So we can write it, we can omit it, but I need it. That is why I have written 1 is equal to L square plus M square plus N square. Now next length is ON. What is ON? ON is the projection of OP on the line. And how to calculate the projection on the line? If you know the coordinates, this is 0, this is x. So the projection is x dash minus x multiplied by L plus y dash minus y multiplied by M, z dash minus z multiplied by N. So here x dash, y dash, z dash, they are simply 0, 0, 0. So this projection will be Lx plus My plus Nz. I hope this point will be clear to all of you. We are calculating the projection of OP on this line, and element of the line are known. They are given to us, element. So, and this point is also known, 0, 0, 0. So the projection of this OP on the line ON will be x minus 0 into L plus y minus 0 into M plus z minus 0 into N. So that is going to be Lx plus My plus Nz. Is it okay? Now let us continue. So we have substituted for ON as well. So we have obtained the result like this. Now this result can be rearranged. How to rearrange? First of all, calculate L square outside. You can observe that x square will be cancelled. From here also you are getting, from here you are getting plus x square, from here you are getting minus x square when you multiply by L square. So that term will cancel and you will be left with L square into summation of M y square plus z square. Now the same thing will happen. Take out M square and the rest of the terms within summation. Take out N square, rest of the terms within summation. And then the product terms, minus 2, take Mn outside, then you will get summation Mxy inside. Similarly, minus 2 NL summation Myz you will get inside, minus 2 Ln summation Mzx you will get inside. Now, the question says that moments and products of inertia of the rigid body about 3 mutually perpendicular axes OX, OY and OZ are known to you, and you are calculating the moments and products of inertia about a given line having DC's element. Is it okay? And I already told you, for that we are going to use capital A, capital B, capital C, capital D, capital E, capital F. What is capital A? That is the moment of inertia of the rigid body about x-axis. So this term will be replaced by capital A. So this is going as AL square plus BM square. This term is B. This term is capital C. This term is D. This is E. This is F. D, E, F. These are the products of inertia. So ultimately we have obtained the result. Result is moment of inertia about the line ON will be nothing but AL square plus BM square plus CN square minus 2D Mn minus 2E NL minus 2F Lm. Observe one thing, that is LMN XYZ, they are rotated cyclically. That means A will be replaced, A, then B will come, then C will come, L, then M will come, then N will come, and so on. So that is simply the cyclic rotation. Here also minus 2D Mn. So M will be replaced by N, N will be replaced by L. So the next term will come like this. This N will be replaced by L, this L will be replaced by M. That is the way to remember the result. Now, this is the case of three-dimensional rigid body. Now let us see what happens if it is two-dimensional body. Let us see what happens if it is two-dimensional body. I told you that if the body is in the plane of the blackboard, if it is two-dimensional, then only the moments and products of inertia about this line ON, if it is in the plane of the blackboard, then this term will come, this term will come, and this term will come. So, moment of inertia about a line in 2D. It will be AL square plus BM square minus 2 FLM. Why? The rest of the terms, these are C, D, E, these are all 0 because they involve the z-axis. So they are going to be 0. So the moment of inertia of a lamina about the line ON, if it is in the plane of the blackboard, two-dimensional lamina in the plane of the blackboard, will be AL square plus BM square minus 2FLM, where A is moment of inertia about x-axis, M is moment of inertia about y-axis, and F is product of inertia about OX and OY. Now, one more thing. You know the value of L also? L is cos theta. M is sin theta. Why sin theta? Because there the line will make an angle 90 minus theta with the y-axis. So once the angle is 90 minus theta, you know what is element? that is the cos of the angle in between. So here it should be cos of 90 minus theta, and cos of 90 minus theta is known to you, that is equal to sin theta. So moment of inertia will be A cos square theta plus B sin square theta minus 2f sin theta cos theta. That's all for today. So we found the moments and products of inertia about a given line in 3D, about a given line in 2D. Now we are going to do plenty of questions from the next time using all the theorems, all the results which we have obtained till now. So some important questions will be taken care of from the next time. So that's all for today. Thank you very much.